Okay, so we have this. We have our int list type class, and we've got these. We've got insert, find, delete, print, size, and a default constructor. So what we're going to do now is we have to add in those big 4 member functions that we're supposed to have in every class that uses pointers, or uses dynamic memory. So what I've done is I've added some statements to my code here, to my client code, that will break if I run it right now. Okay, so I've got this is how far we were up to this point. So what I've done is I've added a declaration of a new list object, and then I'm deleting something from that new one, and then I'm printing both of the lists out. And so when I print this out, list 2 should be the same as list 1, but with a 3 missing, right? And list 1, or list, should still have the 3 there. Okay? And then I've done the same, and so this is invoking the copy constructor. So I need to write a copy constructor to fix that. And then down here I have the same thing with assignment. I've assigned list back to list 2, and then I deleted a 4 from list. So now list 2, they should be the same thing, except list should be missing a 4. List 2 should not be missing a 4, right? So let's see what happens when we run this. Okay, so looks like what happened was when I deleted the 3 from, hold on a sec. When I deleted the 3 here from list 2, the 3 from list also got deleted, right? Because here list 2 and list are both 5, 4, 2, 1. So they're both, the 3 got deleted from both lists, which is not what should happen. And then here when I did this assignment and then I deleted a 4, the 4 got deleted from both lists instead of just being deleted from list. Okay, so we're going to see if we can fix that. So I'm going to go to my header file, and I'm going to add a copy constructor here. Oops, what am I doing? Constant list type ampersand copy. Save that, go over to my implementation file, and let's do a copy constructor. So that's int list type int list type int list. Oops. Okay. I lost my thing. Here we go. All right, so we're going to need a cur pointer, a current pointer that's going to point to the already existing list and go down it one node at a time. So node star cur pointer gets copy me dot list. Does that make sense? Okay. And then we're going to We need to go down the entire list, so we're going to say while cur pointer is not equal to null. Mean what? I was going to stop and see if anyone's paying attention. Cur pointer? Well, right now it's pointing at the first item in the list. I think I need to make the copy first before I increment it. So I think that's actually going to be the last thing in my loop. Yeah. Sure. So, yeah, okay. So basically what we want to do is just insert into the calling objects list. We want to insert cur pointer arrow data. Right? Now, I think there's one more thing we need to do before we call insert. Because right now when we first start this constructor, what is the list data member? Garbage, right? So if we try to insert some data into a list that's currently pointing at garbage, what do you suppose is going to happen? I don't need to know exactly, I just need to know that it's not good, right? So let's set list to null first. Okay, and that also makes it so that if cur pointer starts off being null, then we have the correct result, right? Okay, so then inside here we're just going to insert cur pointer arrow data into the list and then move cur pointer down to the next item in the copy me list. How does that look? Same, yes, okay. So that's the same as I have there, right? Yeah, same thing. There's not much to it, is there? All right, so let me try running this. So actually, before I type numbers in, why don't we predict what's supposed to happen? So let's look at the client code again. Okay, so we're creating a new list. I'm going to type in, so list is going to equal 54321, or maybe, yeah, I think 54321, right? I'm not sure about the order, but it doesn't matter. And so I'm going to create a new list called list2 that should also be 54321. And then I'm going to delete 3 from list2. So list2 should be 1, 2, 4, 5. List should still be 1, 2, 3, 4, 5, right? So it should be 1, 2, 4, 5, and don't worry about the order. I'm not paying attention to that. But list2 should be 1, 2, 4, 5. List should be 1, 2, 3, 4, 5. Oh, I already started. Oh, we've got 2 of them going. Oh, deleted the wrong one. Okay, try again. So 1, 2, 3, 4, 5. List 2 didn't work. 5, 4, 2, 1. So I deleted the 3 from both lists. Okay, let's see what I did wrong. Okay, so this here is this copy constructor here that you see commented out. This is the one I was just using half an hour ago that was working. So let me take that out of there. and put it up here next to the one we just wrote. And looks to me like they're exactly the same. Okay, here's what I'm going to try. I'm just going to start trying things now. Instead of calling insert, let's actually do it manually. So I'm going to say node star new node gets new node. So I'm creating a new node, and then I'm saying new node, the data part of new node gets the data part of whatever the current pointer is pointing at. And then the next part of new node gets list. And then list gets new node instead of insert. Looks like in all right, should we try it again? Thank you. Oh yeah, you probably saw the red squiggly, yeah. Those red squigglies that I still ignore. Okay, it worked that time. Right? That's what we were expecting. List 2 lost the 3, but list is still 1, 2, 3, 4, 5. Okay, so for whatever reason, it didn't work when I had the insert in there. Let me, I just want to play with that for another minute. At least. So, sorry? With the insert? Okay, so I wonder if there was some sort of an issue with like a certain file not getting updated correctly or something. 1, 2, 3, 4, 5 minus 9. Yeah, it's working. So so there must be something about like maybe the implementation file didn't get saved in between or something. I don't know. Anyway, we have something that works now, right? Okay, any questions about the copy constructor? So I feel like yeah, go ahead.
Why are we sending multiple lists?
Okay, actually, I was thinking that I should probably just slow down here a little bit and draw a picture anyway, so why don't I just do that? So okay, where did it go? Here it is. All right, so here's our copy constructor, and let's say we've got I guess I'll just do 3 in the interest of time. Okay, and so here, this guy right here is going, actually I guess off of me. So this guy right here is copy me.list. And let's say here we've got 1, 2, 3. Okay, so that's our starting situation. So what we're saying here in the copy constructor is we're going to create a new pointer called cur pointer that points to copyme.list. Points to the same thing copyme.list points to. So that's going to look like this. Okay. Then I say, okay, well, so over here someplace we have list. Okay, so let's see what happens if we just leave list as pointing at junk for now. So I will represent that with an arrow kind of pointing out into space. Okay, so let's say we leave it there and we say while cur pointer not equal to null. Okay, it's not equal to null. So what we do is we say insert cur pointer arrow data. So what that's going to do, let's go find insert. So there's insert. What that's going to do is I'm going to create a new node. Okay, so there's my new node. And then I say, okay, that's temp. Temp arrow data gets num, which was 1. And then temp arrow next gets list, which means this is going to point out here into space. Maybe that's okay, actually. And then I say list, then I say list gets temp. So list is still pointing out into space. So I'm not gonna it's harder to do this when I will call a function call, huh? So anyway, I think the easy way to say it is that clearly at this point we would prefer to have list if I say list gets temp, I'm sorry. List, when I say, okay, so I just said temp arrow next gets list, so that's what I've got right now. The next thing I have to do is say list gets temp, which means I'm going to say list points to temp. And then I'm done with my insert function, but that's really not how I want the picture to end up, right? Really how I want the picture to end up is I want this list arrow next to be null. Otherwise, it's not really a list, right? Okay, so, well, when
it's not a list if it's null.
Right. So, if I continue this process, what's going to end up happening is at the end, I'm going to end up with a list, and the last node in the list, instead of pointing at null, is going to point at junk. Okay? And actually, it's probably easier to think about it if you just imagine the case where, maybe this is how I should have answered it to start with. If you imagine the case where copy me.list starts off being null, and if I leave this out and never enter the while loop, then the resulting list I get isn't going to be null. It's going to point to junk. Yeah?
Your existing code would break. Your existing prime code would break too, right? Because when you go to print the copied list,
yeah.
it would just be an infinite list.
Exactly, yeah. Or it would crash.
Crash.
Yeah. Okay. Okay, let's bring that back. And let's actually okay, how do I, there we go. All right. Any other questions about the copy constructor? We're going to do kind of the same thing again now, I think, with the assignment operator, and I will try to do a better job of explaining it this time. Oh, I guess I should have saved that, huh? Oh, well. Nope. No such luck. Okay. Let's go back to our client code. So the copy constructor, the discussion got a little convoluted. For some reason, it wasn't working at first and all that. So let's see if we can have a little more luck with the assignment operator here. So going back to our client code at the bottom, we're going to have two lists, list and list 2, and I'm going to assign list 2 to list, and then I'm going to delete 4 from the list. So when I print this out, list 2 should still have a 4 in it, but list, the 4 should be gone. And here we have list 2, the 4 is gone, but list, the 4 is also gone, even though it shouldn't have been gone. So we're going to try to fix that situation, right? So I'm going to go to my header file, and I'm going to add an assignment operator. It's going to return an int list type. Sorry, did I miss something? Oh, without an assignment operator?
This one's still 5432.
Okay, so there's my header file, assignment operator. Any questions there? No? Okay. So now I'm going to write my assignment operator. I think I'm going to, do it without the using insert this time, just because it's going to be easier for us to draw a picture without having to worry about the parameters being passed and all that stuff. Okay, so let's try it without insert. So in case you got a little lost when I was explaining what was happening there, drawing the picture and stuff, I think it'll be easier this time because I'm not going to use insert. We'll find out. So when you think about writing an assignment operator after you've written the copy constructor, what do you think about in terms of how those two functions compare?
When I found 3, they were particularly similar.
They were what similar?
I think it was.
They were similar, okay. So they are very similar. What's the difference? Are they exactly the same?
No, I mixed them.
Okay, so in the assignment operator, so conceptually the main difference is that in an assignment operator, you're copying something into an already existing list, an already existing int list type object. In the copy constructor, you're copying something into a brand new int list type object that hasn't already existed. So the difference is, one, in the assignment operator, you need to use delete to get rid of what was there before. And two, one other difference. You have to check for because you're deleting, you need to check and make sure that you're not it's not self-assignment. Okay, so we talked about that when we did the my string class, right? So those are real. Oh, and then actually there's a third difference in the assignment operator. One more. It returns a value, right? So it just returns star this at the bottom, right? So it returns int list type. The name of the function, the scope is int list type. The name of the function is operator assignment. Okay, so assignment operator, the first thing I always type is the if statement. Okay, there's different ways to do this. This is just sort of a pattern that I'm used to. So I'm going to say if this is not equal to ampersand right, and then I'm going to do the assignment, and then at the end I'm going to say return star this. Okay, so now I need to do what? What should happen inside here? Lots of. Say again? Same thing as my copy constructor? Okay, so I could just say like this, right? Right. Okay. Okay, so do I have to delete before I do this? Actually, this should be right. Oops. So what about delete? Where does the delete go? Okay, well, here's the first place where I assign list, right? I need to delete before I do that. Does that make sense? So that goes back to the sort of rule of thumb I talked about when we were talking about pointers. Every time you assign a pointer, you should be checking to see if you need to delete something first, right? So I'm assigning a pointer, and yeah, actually list was pointing at something else before, so I'm going to delete it first. And I'm actually, these first two statements could be in any order, but for some reason this just seems right to me. Delete the list, right? Then set up, yeah.
That works.
I think so. Why? What?
You need to delete every node, right?
Oh. Good point. Oh yeah. Okay, so it works in the sense that it doesn't break my program, right? But that's a good point. I totally missed that. So I don't want to go too far down that path right now, so let's hold on to that. But you're right. We need to figure out a way to delete the entire list, not just the first node in the list, right? So let's hold on to that. Okay? Yeah.
Can you, second question, can you call this destructor from inside here?
No, you cannot explicitly call the destructor. Yeah. So, so probably what we would want to do is have a private function, auxiliary function that handles deleting a whole linked list. We can call that from here and also from our destructor. Okay, or not, you know. But okay, so let's just pretend we've dealt with the deleting thing, and so is this a good? Are we done? I think we might be. However, I'm going to do it without the insert. So if I'm not going to use the insert, what am I going to do instead? Make a new node. So node star, new node gets new node. And then I have to fill in the fields, right? Fill in the data members. So new node, arrow, data gets right dot list. No. It's cur pointer, right? Everyone understand why cur pointer? Because cur pointer is the pointer I'm using to point at the other list. Okay. Then what about the next field? We're going to insert it at the front, right? So we're just going to say new node arrow next gets list. And then list gets new node. Okay, so let's stop right there for a minute and let's draw some pictures. And this right here is right dot list. Okay, so we've created this cur pointer. So that's going to be like this. Cur pointer, and we've set it equal to right dot list. So it's going to start off pointing at right dot list, and then we need to represent the calling object, the list data member of the calling object. So let's draw a picture for that. Here we have, I'm going to call this arrow list. Okay, so this is the list that we're trying to construct. Okay, so, and let's see, we just set that to null just now. So let me make that a little bigger. Okay, so this statement right here, list gets null. That's why that's null, right?
Because we're adding stuff behind it.
Sort of, yeah. Yeah, that works. We're adding stuff behind it. So we need, if that, this is, yeah, so, okay. I thought I was going to have a better way of saying that, but then I didn't, so I stopped. Okay, so now cur pointer is not equal to null, so we come inside the while loop, and we have a new node. With new node pointing at it. So here's my new node. Actually, I need to draw it a little higher. Let's put it up here. There's my new node. And so this thing right here is called new node, and it points to that new node that just got created. Okay, so that's the result of this first statement right here. Node star new node gets new node. Now I'm going to say new node arrow data gets curve pointer arrow data. What's curve pointer arrow data right now? 1, right? So that means new node arrow data gets 1. Then new node arrow next gets list. Well, this arrow list is null, so that means null here. And then list gets new node. So now list, instead of pointing at null, is going to point at new node. Okay, so at this point, I have a properly constructed list with one node in it, right? So now I'm down at the bottom and I say curve pointer gets curve pointer arrow next. Okay, back up to the top, curve pointer is not equal to null. I create another new node. Oops. And now new node is pointing at this new node. I guess I should have named it something different. That sounds kind of confusing. Huh? New node is pointing there. And so I say new node arrow data gets curve pointer arrow data. So what's curve pointer arrow data right now? It's 2. Then new node arrow next gets list. Right? And then list gets new node. And now I once again have a properly constructed list with 2, 1 in it. If you start here at list and follow it down. Curve pointer gets curve pointer arrow next. Back up to the top, curve pointer is still not equal to null. Create another new node. I realize this is a little tedious, but I think we probably important to just get the whole thing done here. Okay, so that's the result of this first statement inside the while loop. Now new node arrow data gets curve pointer arrow data. So the curve pointer arrow data is now 3. New node arrow next gets list. And then list gets new node. Okay, so now I once again have a properly constructed list. If I start here at list, I get 3, 2, 1, null. Now I say curve pointer gets curve pointer arrow next. So that makes curve pointer now null. Oops. Go back up to the top of the loop. Curve pointer is now null, so I'm done with my loop. And I have correctly recreated this whole list over here on the left. Okay? Any questions about any of that? Okay, so I would really encourage you, if you feel a little fuzzy about this, either sit down and work it out on your own, draw a picture, okay, make sure you understand what's going on here. You can go back and watch this recording if you want to, but I think this is like, pretty critical. If you're not following what we just did, you need to sit down and make sure that you can. Okay. All right. We're going to take a break, 10 minutes. So we'll be back at a little after 9:30. All right, so let's go ahead and run this. Maybe first we should just say what we think the output is supposed to be. Oops, hold on, let me get rid of this. No, let me not get rid of that just yet. Back to my client code. So if I type in a list 1, 2, 3, 4, 5, I delete a 3 from list 2. At this point, list 2 should be 1, 2, 4, 5. List should still be 1, 2, 3, 4, 5. And then I do this assignment. So now at this point, they should both be 1, 2, 4, 5. And then when I delete the 4 from list, this 2 should still be 1, 2, 4, 5, and list should be 1, 2, 5. So it looks like that's what we predicted. Okay? All right. What's next? Let's go back and think. Ooh, that's not what I meant. Why is it doing that? Thank you. All right, so taking a step back for a second. What we were doing is we were trying to fix up our class so that it included the big 4. And so just as a little bit of a digression here. In the textbook, what he calls this is he calls it fixing the value semantics. Is that right? Yeah. So I'm not sure exactly I understand why that term, but I'm okay. I'm going to just go with it. Okay. So what we're doing here is we're fixing the value semantics, which apparently means that so we can use the assignment operator and the copy constructor in our client and have it behave as expected, right? Okay. So I think we've actually done that. We already have the default constructor. So the only thing missing now is a destructor. And also the other thing we still have to work on is this delete right here in the assignment operator, right? So I think at first, just to keep things simple, I'm going to just, even though those two things are going to be exactly the same code, I'm going to just insert the code right here in the function itself. Probably not the, I mean, if you were going to do this, I would say you probably want to make a separate function, and maybe I will eventually, but I want to keep it so that if we end up needing to draw a picture, it's simpler. So how are we going to delete an entire linked list? How are we going to do that? So I think I can still, let's just go back to this big picture here, and let's say that this picture here is a picture of this arrow list. And all this stuff is gone. You get the point, I guess. I'm sure there's a better way to do this. Okay. Oh, and this is gone too. All right, so we want to delete this entire thing, right? So let's start by getting a cur pointer pointing at the first item. Because we can't just say delete list, right? Because then we'll delete the first node and we won't have access to the rest of it. And we can't just say list gets list arrow next and move it down here, because then we won't have access to this one to be able to delete it. So we're going to create a cur pointer and set it equal to list. Okay, so let me write that in here. So, we already declared it down there. Let me just call it something different. Temp pointer gets list. Is that right? Okay. So I guess I need to fix this. And then now what we can do is we can move list down one, and we can delete temp pointer. Does that make sense? So I'm going to say while temp pointer not equal to null, list gets list arrow next, delete temp pointer gets list. What do you think about that? So let's trace it through a little bit here. Okay. So list gets list arrow next. So moving that down here. Delete temp pointer. So that means that's gone. Okay. And then temp pointer gets list. Okay, and then back up at the top, list gets list arrow next, so moving list down here. delete temp pointer, so that goes away, and then temp pointer gets list. Back up to the top, temp pointer is not equal to null, so list gets list arrow next. So now list is null. Delete temp pointer, and then temp pointer gets list is now temp pointer is null. That's kind of irrelevant, I guess. And so we have successfully deleted the entire list. And I suppose what I could do is just reuse this cur pointer, but I'll play with that later before I post this on the website probably. Okay. What's that? Oh, that's running. Yeah, that's a good point. Usually what happens the first time you start trying to correctly manage your memory is that it breaks your program, right? And then you have to figure out why and fix it. So let's see if the same thing happens here. Looks good. Okay. So I didn't break my program, and now I don't have a memory leak. Well, although I still do have a memory leak, right? Not associated with the assignment operator, though. Okay. Where is my memory leak now? No destructor, but that's correct. So, but explain to me what memory leak I have here that having the destructor is fixing. Do I have a memory leak here somewhere? Yeah.
In main.
In main? Sorta, right? But the only place, if I had functions in main, I would, right? Yeah, so actually, I'm kind of thinking that technically speaking right now I don't have a memory leak. If I declared a local variable of type int list type anywhere, I would, but I don't think I have that declared anywhere. Does that make sense? But we need the reason we need the destructor is in case in our client program we have a function that declares an object of type int list type. Because when we get to the bottom of that function, the variable int list type that is on the stack will automatically get deallocated, but all the stuff on the heap that you created that variable is pointing at stays there. It doesn't get deallocated. Does that make sense? So that's what we need a destructor for. And tilde int list type like that. Okay, so that's going to be pretty similar to what we just wrote, if not exactly the same. Node star temp pointer gets list. I guess I could have copied and pasted too. Is it going to be exactly the same? What do you think? Any questions or comments about that?
Do we need to delete the temp pointer after that as well, or?
No, because remember, well, remember when we call delete, what we're doing is we're deleting the thing that temp pointer is pointing at, right? So right here, we've deleted the thing that temp pointer is pointing at. And then I move, and then here I say temp pointer gets list. Now temp pointer is just equal to null, so there's nothing to delete. I think what you may be getting confused about is the variable temp pointer itself, okay, not what it's pointing at. But remember, when you use delete, you're not deleting the variable itself. You're deleting what it's pointing at. You don't need to delete temp pointer itself because why? No. It's on the stack. Temp pointer itself is a local variable on the stack, just like int x or int y. So when we hit the bottom of the function, that local variable automatically gets deallocated. Another way of saying that is the temp pointer itself is an automatic variable. So, and let me say that yet another way, okay? We don't have to delete, the only things we have to delete are the things we used new to create. Right? We didn't use new to create temp pointer. We used new to create things the temp pointer was pointing at. All right, so at this point, either that's clear or it's not. If it's not clear, you may have to, spend 10 minutes tonight. Write yourself a note. Spend 10 minutes thinking about this and making sure that it's clear. Why don't I have to delete temp pointer itself? All right, we should run this and make sure we haven't broken our program. Actually, I don't think that we're calling the destructor anyway, unless I'm missing something. So I guess we're not really testing it. Anyway, that's kind of the funny thing about delete is there's really no way to test it and see if you've actually done it correctly or not. And you can tell if you did it incorrectly in a way that breaks your program, you'll figure that out. But if you've done it incorrectly in a way that means you've got a memory leak, you won't. There's no way to know that just by running it. There are tools out there that I haven't used them. I should probably teach you about them. But there are tools out there that can keep track of this stuff and let you know if you have a memory leak. All right, any questions about our int list type class? So let me just talk a little bit about different types of containers. Okay, this I called it a list. That's if I'm being consistent with the standard template library, that's probably not a very good name, because in the standard template library, the list class actually has an order to it, right? So you can say, if you make a copy of it, the things still have to be in the same order and in the same position. Okay, so really this is more like a multi-set. Remember, a set is just a bunch of items, but there can't be more than one of the same item. And a multi-set is the same as that, except that you can have more than one of each item in the set. So here's what I was getting at. There's kind of three different, there's probably more than three, but there's at least three different ways that we could store these numbers, or whatever it is that we're storing. One is we could do it like this, where it's just in the text he calls it a bag, right? It's just a bunch of objects. There's no order to them at all. Order doesn't matter. A second way we could do it is we could store it in such a way as the order does matter, but things are just stored in the order in which they're inserted. Okay, so that's a second way of doing it. A third way of doing it would be to store things in such a way that they are ordered in order of some sort of comparison. So if the objects are ints, it would be from smallest to largest. If the items were strings, it would be from maybe alphabetical, like that. Okay, so it's kind of three different ways of storing things. In the textbook, in assignment 4, the sequence class, you're going to be doing number 2, which is storing things and keeping the order intact. Okay, so it's a little bit different than what we did here in class. So that's why, when you write your code, you'll have to do it a little differently. Okay. So if you're doing a sequence class instead of this, what I just did, when you insert a new item, where's it going to go? It's going to have to go at the end of the list. In my class I just wrote, when I inserted a new item, where did I put it? The front of the list. Okay? So once you start working on assignment 4 and you read the description, you're going to see that he's going to suggest that you have a pointer to the first node in the list and a pointer to the last node in the list, so that you can insert at the end of the list. Actually, now that I'm thinking about it, I don't remember exactly how he has it set up. He also has a, you're also going to always have a current pointer, like a cursor sort of thing. Okay? And that's also very analogous to how the standard template library works. But basically the idea there is that when you insert after whatever the current item in the list is. So as the client programmer, you can say, okay, start at the first item in the list, then move down 3 items, and then call insert, and that's going to let you insert the new item right after the 3rd item. Did that make sense? Should I say it again? I think you get the idea. So go ahead and read through that. I would say try to read through that by Wednesday, so that if it doesn't make sense, we can talk about it on Wednesday. Okay? All right, the one other thing that I want to do with this code is I want to work a little bit on our comments. Maybe just as an exercise, we haven't really talked very much about how to make preconditions and postconditions, so maybe we can just sort of play around with that a little bit. So the first thing I should mention is that you're going to want to include the prototypes of all your member functions when you do your comments. Okay, these 3 here. No, I can make comments on them. Okay, what's the precondition for the size function?
Be of size type. The object be of size type.
Well, no, the object isn't of size type. The object is of int list type, right? But we don't really need to say that as a precondition, because obviously this function wouldn't be called in the first place if the calling object wasn't an int list type object, right? So you don't have to say things. Remember, the point of the precondition and the postcondition is so that a client programmer looking at your class knows how to use it. Okay? So I don't have to say things like if the parameter is an int list type, I don't have to say something like an int list type object exists, or something like that. Okay? So a lot of times there may not be a precondition. That's fine, yeah.
Kind of a conceptual question. Is it true that you write fewer preconditions if you're writing object-oriented code? Because the class kind of handles the preconditions for you?
I'm sorry, so start over?
Is it true that you write fewer preconditions if you're writing object-oriented code because the class itself handles the preconditions?
Is it true that you write fewer preconditions if you are writing object-oriented code because the class takes care of the preconditions for you? I think what you're saying is that, so I can guarantee that any object of type int list type the list data member is initialized. So I don't have to include that in my precondition because my class itself is guaranteeing that to be true all the time. So, and that's where the class invariant comes in. Okay, so in your implementation file, you're going to have a class invariant that says the list data member is always initialized. Does the client programmer care about that? Client programmer doesn't care about that. They don't even know there's a data member, a list data member, right? So that's a comment that goes in the implementation file. Okay, and you don't have to have it as a precondition because you're guaranteeing that yourself. Is that kind of what you're asking? Okay, kind of. Okay. All right. So I don't think there's a precondition for the size function. So a post condition would be returns number of items in the list. That make sense? Or maybe if you want to, you could say it, sometimes you say post conditions as sort of observations about reality, right? So you could say number of items in the list has been returned. Okay? Either way is fine. It's probably a little less convoluted to say returns, number of items in the list, right? Let's, what about print? Does it have a precondition? Print's kind of an awkward one because in a real class we probably would not have a function named print that just printed the C out. We probably have an argument telling it where to print. Here's what I'm thinking. Often when you've got a function that does input or output, there's a precondition about the state of the input stream or output stream. So we could say something like cout is ready for writing. In a situation where we were working with an O-stream parameter, we would say whatever that O-stream was is ready for writing. Okay, which means that if it's a file, it has to be open. It's not in an error state, whatever. Okay, and then post would be the items in the list have been printed to cout separated by spaces. Okay? Because, you know, who knows, maybe it could be each on a new line, right? That make sense? Okay, how about, does it make sense? Now, just to check yourself, take a look at that, pretend that you don't really know what print does, and see if that comment will tell you what it does. The items on the list have been announced to cout separated by spaces. Yeah. Okay, so even if this was called, you know, elephant, now that I've got my post condition, I'll know what happens when I call that function. Insert. Is there a precondition for insert? I don't think so. If we had a situation where the size of the list was limited, then that might be a precondition, that the size of the list is one less than the max size. Okay, but in this case, we don't have a limit on the size. So I don't think there's a precondition. Postcondition is that num has been inserted into the list. Okay? Sometimes these can become a little bit obvious, but you just got to remember that this is for someone who, sometimes it seems like it's a waste of time because, you've been working with this program for so many hours that how could anybody possibly not know what insert does, right? But we might as well just say it explicitly. Yes?
Should you specify that it inserts at the front of the list?
That's, in this case, I would not, because that's actually undefined, right? I could actually change the definition of my functions so that it gets inserted someplace else, and that would be okay, right? So I'm not actually telling the client programmer anything about where this thing is going to be inserted. Okay? Good question, though. I mean, in a class where order mattered, that would definitely be part of the post condition, right? Fine. Is there a precondition? I don't think so. I don't think there is. Okay, so the post condition is, okay?
Returns an item that was found. Well, just use the blanket, it's not there.
Well, if it's not there, what can we say about if it's not there? Did we print a message if it wasn't there?
The data was not found.
In the client side.
We did that on the client program, right? And so it's actually an interesting question because, okay, right, we definitely do not want to write a message like that in our class, right? Because the client programmer may not want that output to get printed out if the object isn't found in there. So what happens if it's not there? Found is false. Okay. Any comments or suggestions or questions about that post condition? So here's an observation, okay? I haven't mentioned the parameter target in this post condition at all. All I said is returns an item if it was found. Well, what item is it that we're talking about here, right? So we want to try to be a little more precise than this. Maybe we could say, right, for some reason it works better for me if I start with the if. If target is found is set to true, and target is returned. If target, or I guess I could say otherwise, found is set to false, and return value is undefined. Does that make sense? Any other suggestions or comments about that one? Okay, let's do one more. Delete. Is there a precondition on delete? I don't think so. Post condition. If num, I guess I could have called it target again for consistency. If num is found, it is one occurrence is that spelled right? Is removed from the list and found is set to true. Otherwise, found is set to false and list is unchanged. Okay? All right, let's leave it at that for now, and I'll see you on Wednesday.